Good afternoon, everyone. My name is TJ Willits, and I'll be the moderator for today's presentation, Hydrotech Direct-to-Disc Application, a cost-effective pre-treatment of surface water intake. Thank you for your time today and joining us for this presentation. Before we get started to the webinar, Veolia is a very safety-dedicated company, and we start off all of our presentations with some kind of safety moment. So just wanted to take a quick second, though this is a webinar. I just wanted to recommend everyone to take extra precaution, especially for those in the Carolinas, listening to the weather advisories and make sure that they stay safe in that period of time. So please be safe, and I'm sure that everyone on here will appreciate just a few moments to make sure that we all stay safe in our jobs. Just a few moments. You should be hearing me talk now. If not, I would recommend that you work on the two audio options, either calling in on the phone or on the computer audio. One other note, this webinar is being recorded and it will be sent out to all the participants tomorrow via email. So be on the lookout for that automated message. Throughout the webinar, we're going to be taking questions. All your lines are muted, but if you want, you could ask questions using the question panel on the right side of your screen. So go ahead and feel free throughout the presentation to jot some notes or questions in that panel, and we'll try to address as many questions as possible at the end of the presentation. A little bit of an introduction about Veolia. Veolia is the world's largest environmental company. We have three key pillars, and that's water, waste, and energy. We try to maximize the resources in these three key areas, water being the largest focus for Veolia. In terms of what Veolia Water Technologies does as a company, we have a wide variety of services, customer deliverable applications in terms of what we provide, such as design build, turnkey solutions, commissioning, and several services that support projects after they've been executed. The core of Veolia Water Technologies is obviously technologies. Our company has over 350 state-of-the-art technologies, and you can see those are some of the ones that we featured here on the screen. Today we're going to be talking about mainly one, the Hydrotech Discfilter, but we also use these technologies to combine them to provide the best process for our customers. When we look at just Hydrotech Discfilters, you can see that this technology is a widely recognized and reliable technology. We have over 10,000 units installed around the world. It's installed in 50 countries and in every single continent except for Antarctica. At this time, I'd like to introduce our speaker for today's presentation. Bridget Finnegan is a process engineer at Veolia Water Technologies Industrial Project Group in Pittsburgh, Pennsylvania. She earned her BS in Chemical Engineering at Penn State and has worked for Veolia for almost 5 years. Bridget specialized in advanced process analysis and design in various biological and solid separation technologies, including drum and disc filters. She has provided both process and commissioning support for several of Veolia's highest visibility projects in the oil and gas, power, and mining industries. Without further ado, I'd like to hand the webinar over to Bridget Finnegan. Bridget.
Thanks, TJ. Today I'm going to be talking about the comparison of Discfilter with conventional technologies, give a sort of a brief typical project design overview of what it might direct-to-disc process would look like. Then I'm going to describe the Discfilter, how it works, its operation and maintenance, and then I'll end with a couple of case studies and, as TJ mentioned, some time for questions at the end. So the conventional technologies for intake water, for make up the cooling towers, for instance, one of them common ones is ActiFlow, which is a high-rate clarification. DAF, dissolved air flotation. There's solids contact clarifier, or just conventional clarifiers, and sand filters. Discfilter has a couple advantages over these technologies. One of them is footprint. Another one that we focus on today is the CapEx. That is just, it tends to be a lot cheaper for the capital expenditures. So here's a sort of a general graph of how the Discfilter compares CapEx as the flow rate increases necessary for the intake. So you can see generally as the flow rate intakes, the flow rate necessary increases, then the cost benefit increases as well. This is taken from a comparison that we've made from a couple of our projects worldwide. So the sweet spot for our direct-to-disc application is for where you have peaks up to 50, even up to 100 ppm of TSS, and the disc filter can remove it down to 5 milligrams per liter. It's well suited for a variety of loads. Like when the load changes quickly, it doesn't really it handles that well. And we choose the cloth and the mesh size according to our experience and know-how from our installations. So for the process overview, this is what a typical direct-to-disc application would look like. There's the bar screen, which any intake structure would have, and then coagulation, flocculation, and then directly to the disc. And then the filtrate from the disc filter could be used in process water, service water, etc. The coagulation and flocculation will depend on the application, what the client needs, what kind of treatment upstream of the disc filter, and the disc filter just removes the solids. The backwash from the disc filter could then be thickened in a thickener, conventional thickener or otherwise, and then dewatered in a filter press. So how does a disc filter work? So you see at the bottom right of your screen there, the influent comes in the influent chamber, fills it up, and overflows into the discs. So the disc filter, Hydrotech disc filter, is an inside-out filter. So the influent water, the raw water, flows into the discs and then out both sides of the disc into the effluent tank. Both sides of the disc are covered with the filter cloth, which is permeable, and the solids are kept within the disc. So as the effluent tank fills from the water going through the disc, it overflows into the effluent chamber and then out by gravity. The whole system is operated by gravity, the influent, the effluent, and the effluent. And you can see as the solids begin to build up on the filter cloth as the water is going through it, and it takes more and more pressure for the water to push through the filter cloth, and so the water level rises. So when the water level rises to 250 millimeters, it triggers this level switch that you can see near number 3. And when it triggers the level switch triggers a backwash. So the backwash is taken from the effluent tank in its own unit, put through the backwash pump, through the backwash spray nozzles that you see at the top. This is happening while the discs are rotating, and it's kind of difficult to see in this two-dimensional image, but these discs, the dirty ones that have the solids built up, are being rotated out of the water, and clean discs are being rotated into the water. And as this rotation is happening, the dirty discs are being sprayed clean from the backwash nozzles. So when the backwash nozzles spray off the solids off of the filter cloth, they're collected in a trough that's sort of within the disc filter, and the sludge flows out by gravity. So in by gravity, out by gravity, and the sludge also flows out by gravity. So here's a three-dimensional image that I think helps visualize it a little bit better. You can see the influent going into the middle inlet there, into the influent chamber, and it goes inside of the discs. And then out, you can see that blue water is the effluent, filling the effluent chamber and then overflowing out the back there. And then you can see a little bit better how the discs would rotate. So they would move like on this drive they're fixed on, and the backwash nozzles they stay still, and the filter cloths are moved by them, and the solids are sprayed off into the trough in the middle that you really can't see, but you can see the outlet of the trough comes right above the inlet there on the left. Here's a video I thought did a nice job of explaining it. The only difference with the video that you're about to see is that Hydrotech has changed its design so that the backwash nozzles don't move. They're going to be stationary, and in the video they're not. But I think this does a nice job of explaining it. So that's a real video of the backwash nozzles spraying on the filter cloth, and you can see how the discs are rotating. So that's like a cutout of a disc. They're made up of individual panels. There's 28 panels per disc, 14 per side. And you can see the influent going in there, and then that little sort of drum in the middle, and the water is flowing into each individual discs. and out into the effluent tank. You can see the water rising in the effluent tank, overflowing out the back. And when it gets dirty, this is why I like the video, you see the discs are rotating so that the dirty cloth is being taken out of the water and the clean ones are putting in. And meanwhile, the dirty cloth is being sprayed off by the backwash nozzles at the top there. The solids are being pushed off into the trough, which is in the middle of the drum, and then it flows out at that yellow line, if you can see it. So here's a microscopic image of the filter media. This is a 10 micron cloth. It's an absolute barrier, so solids just build up on it and they get sprayed off it. There's nothing fancy about it. If the solids are larger than 10 micron, they're not going to get through, or whatever micron size is in the filter panel. I just wanted to touch on this because for the highest flows, this filter has more surface area, so you can push more flow through them. But if you happen to have a higher solids application, we tend to recommend a drum filter. And drum filter is a technology that's been around a really long time, and it's been used in pre-treatment for about 15 years. So primary treatment in municipal, obviously extremely high solids. So it's nothing that, the solids in a river are nothing compared with that. Again, with excellent results. It's very robust. The filter cloth itself is exactly the same. It's just the configuration of the unit is the difference. And it operates very similarly. But if you have a very dirty river, in Pittsburgh here, we're near the Monongahela, you get peaks, over 200 milligrams per liter, we might recommend a drum. So I just wanted to touch on what that would look like. And so this is another short video of how this works. You can see it's extremely similar to the disc. The influent goes in the middle and goes inside the drum. It's also an inside-out filter. And then when the drum gets dirty, it rotates and is sprayed off. The solids are sprayed off the filter cloth into the trough in the middle. And you can sort of see, this is the solids are being sort of brought up, and then they're sprayed off into the trough in the middle, and then from there they flow out by gravity. So this is a video of a backwash that, just for the video, is put in continuous backwash with the lid off. But I just wanted to show how effective the backwash is. The discs are rotating off, and the backwash is spraying. It's about 108 psi, and the solids come right off. It's very effective. But we don't need to watch the entire video, but you can see how effective it is. This is one of the applications we're most proud of. It's obviously a huge flow if you see that number. 160,000 GPM, more or less. It's been in operation about 8 to 10 years, and they have 18,000 filter panels. So each of those discs, like I said, has 28 panels, and so they have as many units to make 18,000 of those little panels. And if the panels weren't very durable, it would be an operating nightmare if you had to change them out all the time. But in the 9 years of operation, they've changed out 50 panels. So that's 0.3% of the panels that they've had to change in those 8 years. They're an extremely durable material. That backwash, happening like frequently every day, and they're still working very well. This is a 3D drawing of the discs. You can see that they're made up of those panels, and the panels come in and out individually. And if you do, that 0%, 3% of the time you have to change them. They're actually extremely easy to change. This is a video of changing a panel, and it's showing all of the steps of changing the panel. So there's 2 screws. I mean, you have to take off. I guess it didn't show taking the lid off, but there's 2 screws, and then you can just pull out the filter panel just like that. So say, for instance, it got broken for some reason, you would pull out the old panel, and then you would install the new one. Just as simple. So you just put it in there, and then make sure it's flush to the disc so water doesn't get through, and then you put the cover back on with those 2 screws. This entire video is 45 seconds long, and it shows the entire process. So even when it is necessary to change out the panels, it's extremely simple to do. Operators love this unit. Another maintenance thing that we do recommend is visually inspecting the backwash nozzles about once every 2 weeks. So you can see, there's a lever, you can just pull out all of the backwash nozzles, There's a setting on the control panel where you can have a low flow through the backwash nozzles, and you can visually inspect if there's water flowing out. This is one of the reason we talk about all the maintenance is because this is one of the main advantages we have over our competitors that also sell discfilters, because they tend to be much more difficult to maintain, and operators really love our units because it doesn't make them work. So here are the maintenance during normal operation. Like I said, visual inspection about once every 2 weeks, and then it's on a per year basis. So very minimal maintenance needed for these units. Oh, and also while this maintenance is happening, like the removing of the panel and putting it back in, and the visual inspection of the nozzles, if you are not experiencing like a peak abnormal condition, and your operators feel safe to do so, it is possible to continue filtering while those maintenance activities are being performed. So you actually would have no downtime. You would just put the control panel on to not have it not backwash for the time that you're changing the panel, because it takes 45 seconds. So you were able to do the maintenance necessary while the unit is still online. So here are some case studies of our discfilter applications. This is from an installation in Spain. They had a real trouble with biofouling. The zebra larvae were coming in. You can see the picture I have on the top left there. They're about 300 micron, but they can be as small as 30 micron. And then they get through the other intake system, and then they would cause trouble in the cooling tower or wherever else they are, because they would develop. And so they installed the discfilter because it's an absolute filter, like an absolute barrier, and put 25 micron cloth on it. So those 30 micron larvae got caught on the cloth, and you can see the solids in that's a picture of the sludge trough in the middle of the drum filter. I think that show that it all got caught. This is a intake water system in Louisiana. They had real trouble with their sand filters due to channeling, because of a couple of reasons, but the hardness of their water was extremely high. So they replaced their 8 sand filters with 3 Hydrotech filters. So now the system is screens, and then lime softening, cold lime softening, and then the Hydrotech filters, and then it goes to the process. The client was happy with it. One of the main benefits, even besides the footprint, besides the CapEx, was the backwash water savings. Like the volume of water decreased almost by an order of magnitude. You can see the sand filters were about 150,000 gallons per day use of backwash, and the disc filters are about 16,000. So this is the West Deptford power station. It's in New Jersey. It's a 750 megawatt combined cycle plant. Started up in 2010. It needs 7.3 MGD, and they use reclaim water as their makeup water. So that's it's becoming more common, but sort of a unique application. But Veolia designed the system. They have a BioSteer, which is a biologically activated filter. It goes through the screens, and then BioSteer, and then directly to the filters to polish off the solids, and then it can be used in the process. The BioSteer is used for ammonia removal, and then the Hydrotech filters remove the solids. This is in case you happen to have like some existing structures or existing civil works that you would like to reuse. This is an example of that. A facility in Sweden had Passivant filters that were from the 70s, and the spare parts and maintenance necessities were no longer available because it was such an old unit. But they didn't want to, have to knock everything down and build it back up again. And the Hydrotech filters were able to be engineered so that they could be put into the Passivant filter civil structure. So they decreased the number of filters that were necessary, and they were able to reuse the structure that they already had. So the client was very happy. This is from a steel mill in Sweden. They needed 82,000 GPM, and they didn't need any chemical pretreatment, so it just went bar screen, discfilter, and to their treatment, to their factory process. So They're very happy with this, and it's been running for 10 years and running well. This is from a paper mill, 32,000 GPM, quite large facility and also intake water structure. It's been completed for about 4 years. This is the warranties given from Hydrotech. They guaranteed the flow rate and the capacity, also the power and installed power consumption tends to be quite low for these filters, so the client was very happy with the units we installed. This is an American power company that has a plant in the UK. It actually just started up very recently, and it's about 500 GPM, so this is on the lower side, but they still saw some cost benefit for using disc filters over conventional intake systems. So this direct-to-disc is working quite well so far, and it's meeting the client's needs. Here are references for the US power intake references. They're all for makeup for cooling tower. That second one there you can see is for reclaimed water, like the West Deptford that I mentioned previously. But all of these clients, they're working quite well, and we hope to have more soon.
Great. Bridget, thank you so much for sharing all that information with us. The webinar is going to now transition to our question and answer period that we have. I'd like to remind everyone that there is a question panel box on the right side of your GoToWebinar panel. Take a few seconds. You can enter a question there, and we'll try to get to as many as possible. We have a handful ready. We'll start to prioritize those in a moment. While you're typing in your questions, I wanted to remind everyone that Veolia Water Technologies hosts several events like this webinar that you're currently in. We also have several on-site events throughout the year. So feel free to go visit veoliawatertech.com and take a look at some of the events that we have, and feel free to sign up for any ones that seem to apply to what you do. Okay, we have our first question here. First question I'd like to ask is, could a disc filter also be used to treat cooling tower blowdown?
So yes, the answer is the disc filter is applied for many different kinds of applications. It's a solids removal technology. So wherever you need solids removal, the disc filter can be applied there. So it can definitely be used for cooling tower blowdown. Okay.
Another question that we have, it has to do with fouling. How can you prevent fouling on the media?
We do this in a number of ways. Some of them is with chemical pretreatment. If you're able to sort of stop it before it happens, that's ideal. Also, we do recommend chemical cleaning. There's a chemical cleaning nozzles also in the disc filter that can, if you choose to install them, or you could do it manually, where the chemical cleaning system would hook up to the nozzle on the disc filter and spray, sort of similar to the backwash, but not as high of pressure, the chemical onto the filter media, and then it could be rinsed off.
And how often do you recommend that chemical cleaning occurs for these units?
Yeah, so it does depend on your application. Depends, how much, like the contaminants that are in your water and how concentrated they are. We recommend about 3 or 4 times a year.
Okay, we have another question. It's related to the backwash. Can you talk about the volume of water that is used in backwash?
Sure. We estimate that the backwash volume is about 3% of the forward flow. So it's not. We don't talk about backwash time because it's not because the filter continues to filter while it's backwashing. So it's not like there's downtime. So we usually talk about the percent of the flow that is used for backwash. It's estimated in what I would call a typical application to be about 3%.
Okay, looking at our list of questions here. Another question that we have here is related to the different types of pretreatment technologies for raw water. Just wanted to talk a little about what would you select in terms of a traditional clarifier versus a high rate clarifier versus, say, these disc filters.
So, the conventional clarification does work, but it tends to be much larger, which means that it has larger cost for civil works and things like that. where you start to see like more and more benefit for so the discfilter is when you do get into extremely large flows, because they have a very high surface area. If you have large flow and low solids that you don't have much to remove, but it needs to be removed, that's the sweet spot for the discfilter.
And you sort of touched on this, but is there any other treatment area where disc filters or drum filters are not a good technology choice?
Not a good technology. I would say if for thickening applications, you wouldn't use them to thicken solids that are already there. I know there are such things as drum thickeners, but we don't recommend that we use the Hydrotech drum or disc for those applications.
Okay. And we have a question related to OpEx. Can you talk a little bit about the OpEx of the Hydrotech disc filter?
Yeah, so the Hydrotech filter actually has very low power consumption. The power uses are the drive on the motor to turn the discs, like when it does backwash, and also the backwash pump. So those are really the only two uses of power consumption.
Okay. Another question is related to city water filtration. Would this be a good choice for using this for converting from ocean water cooling to city water for new air-cooled condensers?
They can be used for city water cooling. I actually think that would be an extremely good application because city water tends to be very low in solids. It would just be whatever picked up in the pipes. Sorry, I was confused as if it was on ocean water. But you can use the discfilter, or it can be made in any metal that you specify. They have provided them in super duplex if that's necessary, but yes, it can be used on city water.
Another question that we have on backwash volume. It says, since the backwash volume is lower and it's pressurized, is there a savings in sump size and handling costs?
So I would say yes. I mean, it flows out by gravity. The backwashes are typically about 22 seconds long, and in pretty small volume. So you wouldn't need to catch as much all at once, like a backwash of a sand filter, for instance, where you're backwashing and it takes say a half hour for all of that volume, and it happens in a half hour. Where ours it all happens all at the same speed, and it's only for 22 seconds at a time. So yeah, that would be a much smaller sump.
Okay, we have another question about sort of the inlet water quality limitations. Can you talk a little bit about TSS hardness and some other characteristics for this piece of technology?
So because of the mesh sizes, silica tends not to be an issue because the mesh size is broad enough for it to pass through. For TSS, we don't recommend higher than 500 for like a drum filter, but we've done it. And for the disc filter, like I said, we start looking at a drum filter above 100 to 200 range. It depends on the application and how often it's seen and things like that. But the TSS limit, you would see above 500 is where we can do it with confidence, but we've definitely treated even higher than that.
Okay, we have another question here. It has to do with piloting. Can you talk about how you would pilot test this technology? Do you have smaller scale units to be able to pilot test?
Yeah, we do. We have a disc and a drum filter pilot, both individually, that we can bring to site and operate if necessary, or teach you how to operate. It's very simple. We've done it on a number of sites before and gotten some good data from it.
Okay. Another question, it's even though the webinar was a lot about treating raw water, this question has to do with things like wastewater. Is this technology being used in those kind of applications?
Yeah, I would say even the majority of Hydrotech installations, like TJ mentioned, there's 10,000 worldwide units, so it's used everywhere. But a large number of them are actually tertiary treatment, like after an activated sludge. So that's a very typical application. It would be like activated sludge clarifier and then a disc filter for polishing. It can be used, yeah, but it can be used on other solids as well. If you have like an MBBR or even polishing to a clarifier that already exists, it's a very simple unit to remove solids.
Great. Well, it looks like we're nearing the end of all of our questions and also the time that we have allotted for this webinar. If we didn't get to your question, we'll make sure we have someone follow up with the person that asked that question. So don't worry, we'll make sure that we get an answer to the question via email or by phone. Well, at this time, I'd like to thank all of you for taking some time to attend this webinar. We hope it was a valuable time and of your valuable use of your time this afternoon. I would also like to thank our panelist, Bridget Finnegan, for her effort in preparing this presentation and delivering it to you as well. So at this time, it concludes our presentation. Thank you and have a great afternoon.